Good evening. I'm Tom Potowski, professor and chair of the economics department at Portland State University and director of the Northwest Economic Research Center. I'd like to welcome you to Portland State University on behalf of the economics department, faculty, and staff. Dean Stephen Percy of the College of Urban and Public Affairs sends his regrets. He's fighting a nasty cold/virus that has invaded our campus, and he does welcome you here tonight. We would also like to acknowledge the support from Professor Emeritus Helen Youngelson-Neal and Art Neal, Emeritus Professor John Walker, the College of Urban Public Affairs, and the Institute for Sustainable Solutions. We also thank our longtime contributors and supporters, Karen Tosi and Robert McCullough. So we're here tonight for the 2017 Harold Goodhue Vatter Memorial Lecture. And this is our 10th year of doing this lecture. Professor Vatter was on the PSU faculty from 1965 to 2000 and was one of the premier pioneers of economic history. I urge you to read about Harold in the program brochure, about his nearly 90 years on this earth, working in the Roosevelt administration, numerous books and articles, and a passion for the public sector. Now, the passion for the public sector is not romantic, but an analytic belief that the public sector plays a positive role in economic development. Professor Vatter's classes on American economic history were always in great demand. As one student commented, Professor Vatter is not giving us secondhand information about American economic history. He was actually there. Harold had a long working relationship with Professor John Walker, who could not join us today. Harold was also a close personal friend of Emeritus Professor Helen Youngelson-Neal of our department. If you have the opportunity to chat with Helen after the lecture, she can do greater justice than I on relating to you a brilliant man and one colorful character. With that, let me turn things over to Professor Randy Bluffstone to introduce you to today's speaker. And once again, welcome to our lecture series honoring Harold Goodhue Vatter.
It's my pleasure also to welcome you today, not only on behalf of the Department of Economics, but also the Institute for Economics and the Environment here at Portland State University. As Tom mentioned, a critical sponsor of this series is the Institute for Sustainable Solutions here at Portland State. And to say a few words, I'd like to invite up Professor Vivek Chandas, who's a professor of urban studies and planning, and also research director at ISS.
Thanks, Randy. Just a few quick words about Institute for Sustainable Solutions. It's the glue that brings the departments on campus together. It's an attempt to try to really do something that we haven't done in universities, not only in the US, but across the world. It's really trying to figure out how do we get interdisciplinary, transdisciplinary research and education to serve community needs. And so this is a great example of how bringing people from other parts of the world, and this particular person with whom it turns out we found out yesterday we met 20 years ago in Leipzig, Germany, and traveled around Eastern Europe together. Just figured that out yesterday, and a total coincidence that I'm actually here today to describe the Institute for Sustainable Solutions as a sponsor for this. So I encourage you to look at the Institute. We're trying to really bring the light of the Institute a little bit brighter across the region, and we've been working on numerous projects across the region. Many fellows and others in the audience here know about it. Encourage you to check in with me if you want to know more about it, or check out the website, pdx.edu/ISS. Thanks a lot for coming to the lecture.
Well, it's my distinct honor and privilege today to introduce to you Matthew Kotchen. We're very, very pleased to have him here today and look forward to his presentation. Matthew Kotchen is professor of economics at Yale University. His main appointment is in the Yale School of Forestry and Environmental Studies, but he also has secondary appointments in the Yale School of Management and in the Department of Economics. He's currently serving as Associate Dean of Academic Affairs in the Yale School of Forestry and Environmental Studies. And he's also a faculty research fellow at National Bureau of Economic Research, NBR, which is a very prestigious appointment as well. Professor Kotchen's research interests lie at the intersection of environment and public economics, and as well as policy. He has a variety of ongoing projects that use both empirical techniques and theoretical modeling, and they cover a wide range of topics, including energy, climate change, green markets, corporate social sustainability, development, and applied game theory. Matt joined Yale in 2009, but he's held other appointments as well, including at Williams, UC Santa Barbara, UC Berkeley, Stanford, and Resources for the Future. Professor Kotchen recently served as Deputy Assistant Secretary for Environment and Energy at the U.S. Department of Treasury. And during that period, he worked on President Obama's Climate Action Plan. He also represented the U.S. on the governing boards of the Climate Investment Fund, the GF, the Global Environment Facility, and the Green Climate Fund. In addition to the Treasury, in the UN climate negotiations and energy and environment finance efforts, he worked with the G20 as well, the group of 20 countries. Kotchen has also served on the Science Advisory Board of the US EPA and is the visiting chief economist at the Environmental Defense Fund. And it's been a pleasure to get to know Matt a little bit the last couple of days, and particularly to know that he shares with me a love of sailing. So with that, Matt Kotchen. I forgot to mention, please hold questions till the end. There'll be ample opportunity, about a half an hour for questions, and a mic will be passed around to make sure that your questions are heard. Thank you.
Well, hello, everybody, and thank you for the invitation here to speak at this event. I'm humbled by the distinguished set of past speakers and to be included in that group, so it's a pleasure. It's not every day that you show up to go for a hike the morning of before you're giving a talk, which I did today, which is wonderful, and finding out that you actually have traveled with somebody who shows up in the car a week earlier in a period of your life 20 years ago that you don't remember all that well. But we spent the good bit of the morning remembering. So thank you again. Thanks everybody for coming. It's been great to get to know many of you and sort of talk a little bit. And based on the discussions that I actually had in the past half hour here, I thought that I would just jump straight to the Q&A. Actually, not really, almost, but many people have had some interesting things, and I suspect that there's a nice discussion to follow the presentation here. So the topic that I'm talking about is the political economy of climate change, and I think I was originally invited to come and give this presentation back when I thought the political economy of climate change meant something that it necessarily does today, because the politics part of it has actually changed quite a bit. And in the course of this presentation, I'm going to cover a lot of different perspectives and reflecting some of my own experiences, both as an academic, as a government official, as someone who's done advocacy research for the Environmental Defense Fund, and also sort of as an analytical economist. So I plan to start with just a couple of slides, actually with some science. I'm not a scientist at all, and some of you out there might be. I'm going to talk a little bit about how at the very highest level, how an economist sort of sees the problem of climate change, articulates the problem, and starts to think about the structure of a solution to it. Then I'm going to talk a little bit about international progress that has happened for agreements in the United Nations, reflect on this a little bit, and then get at some of the recent changes that have happened in the past couple months for politics, and then sort of end with some thoughts that are actually still being formed in my head as I'm talking. So I'm not sure exactly how it's going to end, but we'll see where we go. So I just want to start out with a couple of slides here that are basically some science. And the science that I want to just present is basically just descriptive science about what's actually going on out there in the world and how do you think about climate as a problem. I realize some of us here may be actually like climate scientists, and some of us may not be at all. So we have a very mixed crowd. This is basically the Keeling curve, and what we've got here on the horizontal axis of this graph here is basically time. And on the vertical axis, we've got the concentration of CO2 in the atmosphere. And these are records taken from Mauna Loa Observatory, and this is known as the Keeling curve. And basically, this shows how the atmospheric concentration of CO2 is increasing in the atmosphere. And literally, these up and down lines are basically the breathing of the planet, sort of where CO2 is absorbed into leaves and sort of captured in leaves, and then decomposition happens and it goes up and down. And of course, I think almost everybody here would be aware that the concentration in the atmosphere of this is increasing through time. And so started out here in 1960 at about 315 parts per million. I think this reading, and I got this graph, was just from a couple of weeks ago, and it's about at 409 parts per million now. So keep in mind this perspective, and now I'm going to just show you the next graph, and so we're going to move sort of back in time. This graph here, this is the graph that I just showed you before with the lines going up and down, and this goes back to the year 1970. So we've got a longer time span, and basically you can just see the data from prior here basically comes from ice core data. So this is basically bubbles and ice that you can go back and you can find, and they've been stored from way back and measure the atmospheric chemistry, the concentration going back in time. And so you can see that this is a pretty, this is an increasing trend. You can say that for sure. Now if we go back even further in time, and so this is basically, if we go back 10,000 years, you can actually see that the concentration starts out here at about just, this is like, 265, relatively flat for a long period of time. And then we move to this recent history, and you can see this sort of increasing, shocking increase in the concentration of atmospheric CO2. And this is referred to sometimes as the hockey stick graph. And for reasons, this is the bottom of a hockey stick, and there's the handle. And when I say sort of science and you think about concentrations and some of the controversy about climate change, nothing on this graph is actually in dispute. So everybody should realize this is just a description of what is actually going on in the atmosphere. Some of the debate, some of the controversy, and some of the science that has actually arisen is sort of what this means. But I think it's quite clear that you could look, there's something drastically has changed, and this is in part driven by the Industrial Revolution and the burning of fossil fuels and taking carbon dioxide that's sort of trapped in fossil fuels and burning it and converting it using energy and converting it into the atmosphere. And so this is a graph, what I've got here to show that this is kind of bringing up to sort of contemporary times and what some of the issues are and some of the things that people care about, is what you've got here is if you actually take the average temperature, planetary average temperature over the past century, and you just sort of plot the years when it was above it and when it was below the average, this is basically what you get. Early on, the temperatures tended to be cooler, and now the temperatures tended to be higher, and based on these records, and this, by the way, is also information that is not in dispute, that the temperature of the planet is actually getting higher, and in each year we're actually breaking more and more records for some of the highest temperatures. So there's an increasing planetary temperature, and now the interesting stuff comes about. If you layer onto this graph, this is the atmospheric concentration of carbon dioxide, and it's sort of increasing here. And it's plotted on this graph, and this graph is showing this relationship. But one of the questions, and where some of the debate, and I would say it's not so much, the debate gets a lot of attention, but I think that scientists actually don't sort of puzzle about it all that much. And the question is, to what extent is this, the concentration of CO2 in the atmosphere, causing this, the increase in temperature? Or are these just coincidental things that are happening at the same time? And if you talk to climate scientists, there's a lot of things that affect the temperature of the planet. The rotation of the Earth. I can't remember all the phenomena. Basically, the Earth sort of has a certain tilt to it, and it rotates around the sun over long periods of time in asymmetric ways, and sometimes closer to the sun, sometimes further to the sun. None of this stuff is mysteries, and scientists can actually figure this stuff out. And based on sort of their scientific models, they can predict to what extent the warming is due to that other stuff. And then you're left with explaining some of this anomalous temperatures based on the CO2 in the atmosphere. And the general consensus among scientists is that this increasing concentration of carbon dioxide, which is driven by the burning of fossil fuels, is causing the increase in temperature that we've actually seen over just the past 80 years here. So I'm going to sort of, because I'm an economist and I'm not a scientist, I'm going to trust the consensus of the science for the purpose of this talk and thinking about it, and actually build the way I think about this problem, accepting the fact that this increased concentration is causing the increase in climate temperatures. So what are the impacts? So the temperature is increasing, and this is just a sort of a list that I put together here of the different areas and different ways that you would expect an increasing global temperature to affect various things on the planet that we in fact might care about. So obviously there's rising temperatures and heat waves. We have rising sea levels. This is because of ice melting and the ocean levels rising, but also because the water expands when it actually is at a warmer temperature. Increased storm frequency and severity, changing patterns of precipitation and drought, shifting agricultural productivity. We've got changing frequency of wildfires, threats to ecosystems and species stability. Some of this comes from if the planet is actually warming and all these other things change, although species and ecosystems can adapt, maybe they can't adapt at the rate at which these changes are actually taking place. There's direct human health consequences. People think that these changing patterns of temperature will actually change the incidence and the distribution of disease patterns, things like malaria. There's evidence that it's actually migrating north as temperatures are warming. And then global conflict and migration. There's an interesting literature arising now that shows how climate change affects increasing temperature and resource availability in the form of water is actually the cause of many sorts of civil conflicts around the world. And so there's a huge literature, thousands or tens of thousands of research papers that study these different types of effects. And these are based on historical studies that look back in time to see how the changing climate has affected these different outcomes. But then there's also forecasting models of how these things are likely to play out in the future. And so I basically pulled a couple of graphs since I'm here in the Pacific Northwest to show some of this stuff. These are from regional analyses that the Environmental Protection Agency has to inform places about the likely impacts of a changing climate in their region, in part to sort of inform and provide information to spur adaptation. So this is a graph of the Northwest, and this is the change in snowpack from 1955 to 2015. And the red dot suggests that the April snowpack is actually going down, and the blue dot suggests that it's going up. Now, this is a clear pattern here based on historical data looking back where the snowpack is actually getting less. I think that if you were to choose this year in particular right now, you might come out with a different graph, given what I've heard about what's going on, which basically suggests that, don't forget one of the things that I mentioned before, the changing temperature doesn't necessarily always mean that things happen in the same direction. It can increase the variability of the impact, so that doesn't necessarily change the conclusion. This is basically looking back in time. But there's a whole bunch of literature and research on climate change impacts that forecast and look into the future. And my point in showing these is not to actually go through these graphs individually, but here is basically forecasts into the future in the Pacific Northwest about, with changing climate, if we continue on as business as usual with our emissions of CO2, how the reduced summer flows of water will actually change in the region. I'm sure you can't read this from in the back or maybe even from the front, but the darker areas suggest that there'd be reduced flows. This is basically forecasts for different levels of sea level rise in Seattle. These are the areas that are likely to be inundated with water either through storms or increasing sea level rise. I think that in other places in the United States, sea level rise is a much bigger deal than it is in the Pacific Northwest. This last one is areas of forecasted insect disease and increased areas of forest fires, so burning, as there will be more drought conditions. And so this information and the research that goes into this is very helpful for one aspect of how you think about climate change. Typically, the way it's partitioned is there's sort of what's referred to as mitigation, which is reducing the concentration or reducing the emissions of greenhouse gases, and then there's adaptation. And adaptation is how you actually adapt to a changing climate. This information is very useful for those trying to come up with ways and structure adaptation mechanisms. This talk is actually not a talk about adaptation, it's a talk about mitigation, which I think is a much more difficult and challenging problem. And the reason is quite simply that if you think about a state like Oregon or you think about yourselves, in order to adapt to a changing climate, it's in your private incentive in order to adapt and sort of protect yourself against the future and sort of not make yourself increasingly vulnerable to some of these changes. Mitigation is slightly different because now you're basically being asked, or the idea is to reduce your emissions of greenhouse gases, but you're not the beneficiary of that behavior. It's the world that's the beneficiary of that behavior, and you incur the personal cost. So it's a more difficult problem. So I'm focused on mitigation here for this talk. And the way to think about this, or to structure this is basically a schematic drawing for the way economists at the highest level study climate change as a problem using these tools called integrated assessment models. In the integrated assessment models, try to combine features of the natural science with the social science and economics to come up with different scenarios and sort of make prescriptions about different types of policies. So if you start out here at the top of this, basically you think about the emissions. So this is the emissions of greenhouse gases, which basically go through sort of atmospheric models of reservoirs and decay, because over time these gases sort of assimilate and they don't stick around forever. Some stick around longer than others. But this leads to an atmospheric concentration of greenhouse gases. And then this concentration of greenhouse gases, through a radiative forcing effect, actually results in temperature change. So this is basically the idea that I showed you earlier on the slide. This right-hand side of the graph is basically the natural science feature of the model, although there needs to be forecasts about what the future looks like in terms of the emissions trajectory. But then this temperature change has impacts. And those impacts are the things that I went through before about how it affects precipitation patterns, how it affects temperature, how it affects agricultural productivity. And these map into damages. And the economics component about this is doing this sort of non-market valuation of figuring out what those damages are worth from an economic perspective. In other words, what is the cost of them in terms of dollars? You experience those costs, these economic damages, and then you've got your economy, which engages in economic activity and produces output. And it is this economic activity that generates the emissions. So you basically have a loop here. And this sort of perspective here, this temperature change, either has damages to things like ecosystem services, but it also can directly affect economic productivity. There's interesting studies now that show about basically people's worker productivity associated with climate variables. On hotter days, people actually don't work as well and they don't produce as much stuff. So some of these things have direct impacts for economic activity. So these models are very complicated. They have a lot of assumptions associated with them, and they're basically run. And what you do is you actually ask the question, given that emissions causes temperature change, and temperature change has these economic impacts, you run this model and you forecast it, and then the question is, what is the optimal policy? What is the right amount of emissions that we should actually have? And I think that when I teach Introduction to Environmental Economics, many times students would say, well, the optimum amount of emissions is actually we should have zero emissions. Why would we want any climate change at all? Well, from an economics perspective, that's not the answer, because we actually benefit a lot from these economic activities that generate emissions. So there's a balancing between these two things. From an economics perspective, what is the optimal way to think about the trajectory of emissions going forward? And there's a lot of complicated things that come out of these models, a lot of controversies about how the model's set up, different functional forms, what's your choice of the discount rate. I want to abstract from that entirely for a moment and focus on one of the things that these models are actually used. It boils down to a particular number, okay? And this particular number is referred to as the social cost of carbon. And the social cost of carbon, what this reflects, for those of you who have experience in economics, this is basically the external cost associated with emitting a ton of carbon dioxide emissions. But what this basically is you could actually think about, if you emit a ton of CO2 into the atmosphere, what are the costs of doing that to the globe? And I mean that really to the globe, of what are the costs of that to everywhere on the planet over all space and all time? So conceptually, this is an idea that is very difficult to estimate, and in fact, probably impossible to come up with a true estimate. Nevertheless, if you want to manage climate change from an economically efficient standpoint, you need to have an idea as to what this number actually is. And I'll explain exactly how this kind of like boils down to how you would think about policy. Well, actually, let me jump down to this in a minute and get back to this process. From these different models, through this process, there's basically, in 2010, the US government under the Obama administration kicked off this interagency working group. And this would basically involve 13 different government agencies taking advantage of the best available science, and was recently reviewed, this process, by the National Academy of Science, and the general approach was actually endorsed. And what this did was look across all the three different main integrated assessment models and said, what is the social cost of carbon? And the estimate, the number that comes out of this process, the central estimate, there are other numbers based on different assumptions, but the focal point number is about $40 per ton. So what does this mean? Just going back to the beginning so everyone kind of has in mind what this means. A ton of carbon dioxide emissions that is emitted causes $40 worth of damage to the planet. And that accounts for the impacts over all space and all time. So what does this mean, and how do you think about this from an economics perspective? This suggests that policies that can reduce a ton of emissions for less than $40 per ton are economically efficient. The benefits to the planet exceed the costs. An important idea here, and the next couple of slides are really going to focus in on this because this is a topic that I've been focusing some research on lately, is that this is a global perspective. This says from a planetary perspective, it's a good deal from an economics perspective to implement any policy where I can reduce CO2 emissions for less than $40 per ton because the benefits are going to outweigh the costs. Okay, this is the global perspective. Now, the question that you might then ask is, well, who cares about the global perspective? Well, there's sort of like a, if there's a global planner that is in control of the planet as a whole, the way I just set up that question is how you would answer it being a good deal. But then you could ask, well, if you're the United States or if you're another region or you're another country, what are the damages of that ton of carbon dioxide emissions to you? The $40 is to everyone, but what about just to you? And so based on combining these different models and these assumptions that go into them with some empirical evidence, you could decompose this $40 per ton, which is the global social cost of carbon, into the domestic damages in any particular region. So what I've got here is this is the percent of the global social cost of carbon, and I've got 12 different countries here in some cases and regions in other cases that are going into these integrated assessment models. And what this says is that the European Union experiences about 15% of the global damages. And where this comes from, roughly, is it's sort of proportional to its GDP with some adjustments based on the vulnerability and damages in different areas. So in Southeast Asia, it's about 13%. In the US, it's about 11%. Specifically, what does this then translate into the dollar value? If you focus on the US number here, basically you go across and let's say it's about $4.50. Okay? So what does this mean? This says that if, from a global perspective, everything that costs less than $40 per ton is a good deal, what this says is if you actually take the perspective of the United States alone, what is a good deal are only those things that can get you a ton of emissions for less than $4.50. Very, very different implications about whether or not you have a global perspective or you have a domestic perspective. And by the way, as I'll get to a little bit later in the talk, this is not just academics here. The distinction that I'm making actually is kind of the focal point of some of the things that are happening in the politics of climate change right now. So, how do you think about this? One of the takeaways that you should have at this point is what you do from a domestic perspective is different from a global perspective, and the global perspective suggests that you should be undertaking a lot more emissions abatement processes or initiatives than if you just have a domestic perspective. And this is the sense from an economics perspective that climate change mitigation is a problem that requires collective action among countries. This is not a problem that any one country can actually solve by itself. And the way that I want to demonstrate this is to go back to a simple game theoretic way, which is basically a prisoner's dilemma approach. For those of you who are recovering from Econ 101 or your intermediate micro, this will be sorry. For those of you, I'm going to try to, for those who haven't seen a graph like that or a chart like this, I'm going to try to explain it. So what I've got here is there's a conceptual tool to emphasize these different ideas where I've basically got two countries. I'm going to consider the world is divided into just two countries, country A and country B. And the question is, do you set policies based on internalizing the global social cost of carbon or the domestic social cost of carbon? Okay, those two numbers from the US perspective, you could think of this as the $40 per ton or the $4.50 per ton. How rigorous a policy should you implement? So country A could choose to do the domestic social cost of carbon or the global social cost of carbon. Country B faces the same choices, and I've assumed these two countries are actually the same. They're exactly identical. The way that you solve these problems to figure out the optimal solution from a country's perspective is you basically assume a country does one thing and figure out what you would do. So if your country A, let's assume that country B decides to only set policy based on its domestic social cost of carbon. Then country B, the red here, is basically indicating their payoffs. You could think of this as their net benefit. So if country B actually country B, so let's just look at this top row, is doing the domestic, country A could choose the global social cost of carbon, get a payoff of 1, or the domestic social cost of carbon and get a payoff of 2. Which one would you choose? You would choose the domestic social cost of carbon and get a payoff of 2, because why should you have a rigorous climate policy when country B doesn't? You're just providing benefit to them at cost to yourself. So in this case, country A would always choose to choose the domestic social cost of carbon. Now let's change country B's strategy. Let's assume B chooses to be altruistic in the sense that it's going to do the global social cost of carbon, have a very rigorous climate policy. Now country A faces a choice of a payoff of 4 by doing domestic or a payoff of 3 by doing global. Which would you do? The way I've set up these payoffs here, country A would do the domestic social cost of carbon again, because again, here it gets the benefit of country B having a rigorous climate policy and it not experiencing the damage from as great a damage of climate change from them, but why should it incur additional costs on its own? So what I just hope that I convinced you of is country A has a dominant strategy to always choose the domestic social cost of carbon. It's individually rational for country A to do that. Country B has the same incentives because the payoffs are the same for both of them. John Nash's idea from A Beautiful Mind, the Nash equilibrium, suggests that this is the equilibrium where each country does its domestic social cost of carbon, each gets a payoff of 2, and this is a market failure and not great from a planetary perspective, because if both chose the global social cost of carbon, they could each get a payoff of 3 for a total benefit of 6 instead of 4. This is the sort of market failure collective action problem associated with climate change. What's individually rational for a country is not individually rational for the collective good. This was a game where I set up where both countries were actually identical. Let's change this now, where I've changed the countries so they actually have asymmetric payoffs, different payoffs. Actually, the point that I wanted to make is this is basically, the problem here is referred to as free riding. Countries want to free ride and not actually have as stringent of climate policy for themselves. They'd rather free ride on the provision of others. The problem, unfortunately, is even more complicated than that and leads to more difficulties, because here I've set up the same game, but I've changed actually the payoffs. To sort of go through this a little bit more quickly, you'll find if you look at the payoffs that each country doing the domestic social cost of carbon is again the Nash equilibrium, the optimal strategy for both countries. But here the difference is that in the last graph here, if you notice, both countries were better off by playing the globally optimal solution. Here, country B gets a payoff of 3, but if country B goes to the global and country A goes to the global, we have a payoff that is together is greater at 6, 2 plus 4, but notice that country B is actually worse off, gets a lower payoff, whereas country A gets a beneficial payoff. There are distributional issues about this as well, where moving to the optimal solution isn't actually necessarily better off for all countries. What I tried to do in some of my research is figure out the extent to which this effect actually comes into play, and I've run some simulations based on one of these integrated assessment models. And so what I've got here, on the left, this graph says if you move from countries playing their domestic social cost of carbon, or the equilibrium outcome, to the efficient solution where all countries choose the global social cost of carbon, who has to abate what? What are these different regions? How much? So this graph here is basically saying that China, when you go to the globally optimal solution, would shoulder the burden of reducing 26% of the global emissions. United States, 15%. Southeast Asia, 10%. So this is who's actually doing the emissions reductions. Then I ask, well, if you actually got to this collective action solution, who wins and who loses? And what I've got on this side of the graph are the countries here. These are the net benefit to different countries based on this model, where India is a large beneficiary, and all these countries and regions benefit, but South Africa, Eurasia, and China are all made worse off, in part because they shoulder more of the burden of reducing emissions, but their benefit of avoiding the damage of climate change is actually not necessarily, is not enough to offset it. Okay? So why is India such a big beneficiary? The reason is because the marginal damages of climate change are considered very high in India because it's already hot, they're at a relatively low level of development, and the populations are very vulnerable to a changing climate. So if you actually move to an optimal solution, they benefit quite a bit, even though they have to reduce, well, relatively small, 5% of the global emissions. One further point I want to make on this, and by the way, this is the most technical aspects of the talk here, is that based on the economic theory, there are winners and there are losers here. But one thing that I know is that the positive bars, so this is just a demonstrative example from a model. These numbers are illustrative, and the point of seeing this is basically to show that there are winners and losers. I wouldn't place too much faith in whether or not these numbers are capturing the true distribution. But the idea here is that these positive bars, the sum of them, is always going to be greater than the negative bars. So on net, the net benefits overall to the planet are going to be positive. And what does that say? This is kind of like moving towards an optimistic note. It suggests that the benefit that these countries get could always be enough to compensate the countries that are made worse off. And in many ways, this is the rationale for some of the trends that we see about climate finance and transfers and development that are associated with climate change, of which I'll have more to say in just a minute. Here, okay, so that's the sort of like economic theory, economist way of setting up the problem as a global collective action problem. Now I've got sort of 3 flashcards, and this is sort of like the history of the United Nations Framework Convention on Climate Change in like 2 minutes, sort of like the greatest hits. So in 1997, there was the Kyoto Protocol, and basically what this was is that the developed countries of the world pledged to reduce their emissions. And as part of this agreement, and ultimately why the US never ratified and signed on, was that the developing countries had no obligations to reduce their emissions. And part of the reason for this was the notion of one of the terms that came out of the United Nations framework is this CBDR. And that is common but differentiated responsibility. And the idea was that we have this problem of climate change, but the developed countries of the world are where all the emissions actually happened. And the developing countries haven't emitted quite as much, and yet they're going to suffer a lot of the damage. So it's just, or it's right, for the developed, richer countries to reduce their emissions and let the relatively undeveloped countries go through their development process. And basically, the history has shown that this agreement was largely ineffective. I mean, one could argue that there's been some things that have come out of this, but generally I think that how this has changed the trajectory of global emissions has been, you'd have to stare really hard at a graph to see any effect. Then comes along Copenhagen in 2009, where ambitions and changes, these meetings happen every year, but this is when the next agreement was supposed to arise. And many people argue that this was a failed agreement. This is when Hillary Clinton was the Secretary of State, and if you may remember the news, some of you, Barack Obama showed up on the last day and flew in and went into a room with the Chinese government and tried to figure out a plan, and an agreement, a global agreement basically failed. Interestingly, from a historical perspective, I don't think that this was a failure, because one of the things that sort of came about is that common but differentiated responsibility idea started to erode a little bit. There was some recognition that all countries, both the developed and developing countries, needed to reduce their emissions in order to get this problem under control. I'll show you why that sort of arises in a little bit. But related to the last graph, a big part of this was the promise of financial assistance to developing countries to reduce their emissions. So here the idea was that there was still that sort of sense of justice or ethics, but it was everyone needs to get this problem under control to reduce their emissions, but there's going to be financial flows and transfers. And in particular at this agreement, there was a goal of $100 billion per year by 2020 in transfers of financial flows to help with developing countries reduce their emissions. Now, up to sort of more current day, the Paris Agreement in 2015. The structure of this agreement is based on something called these intended nationally determined contributions. Whereas instead of a top-down agreement that said there's a cap on global emissions and sort of trying to partition up the different amounts that countries had to reduce their emissions, this was the idea of countries voluntarily choosing how much they were going to reduce their emissions. And this came from, and this is an important idea, both developed and developing countries. So in a sense, there's almost a complete erosion of this common but differentiated responsibility. But notice that what's happening is there's sort of more and more commitments for financing transfers, but it's also the case that countries are kind of voluntarily choosing and submitting how much they're going to reduce their emissions. You could know sort of from the beginning that this is an agreement that is designed to succeed, because it's designed to succeed because everybody could submit to do whatever they want in order to be in it. So in some ways, it's a very tremendous international success, which I'll talk about a little bit more in a minute, but you might actually be concerned that this isn't one voluntary. If I passed around a hat for voluntary donations to provide the food and back, chances are we wouldn't get enough donations to, well, we may in this crowd, right? But generally, a voluntary contribution model is not the way to solve a collective action problem. Okay, a couple of graphs that help you understand sort of that pattern of evolution in international agreements and kind of where we are today. This is a cartogram, which I like, where it basically takes a map of the world and sort of blows up countries based on the magnitudes of what they're sort of interested in here. So this cartogram is basically your historical CO2 emissions. So larger countries are the ones that actually have greater responsibility, some people would say, but historical emissions of CO2. So you could look, this is kind of like where that common but differentiated responsibility arises. But then if I shift and look at the map, so just take a look at this graph for a minute, this is a different version where it's basically people at risk and a measure of vulnerability from climate change impacts. And you can see that it's basically like completely the opposite. And this is where that common but differentiated responsibility comes about, but it also suggests increasingly why the idea of many developing countries leaving it up to the developed countries to take care of this problem is no longer the way of the future, because the developed countries are the one where all the damages are actually going to occur. Contributing to that, this is a graph where I've got sort of 1990 forecasted out to 2040, and this is the actual and forecasted emissions from OECD countries. You could read this as the wealthier countries or the developed countries, and non-OECD countries are the developing countries. In the future, although historically it's been the OECD countries or the developed countries that have done a lot of the emissions, that's not where the future is. The forecast is it's these developing countries where all this emissions is also going to take place, and also where the most of the damages are going to happen. So you can see that trajectory from Kyoto to Paris. There's a completely different dynamic where developing countries are no longer, this is your problem, you need to take care of it, where they're actually shifting to more of the lead of, this is really our problem, we need to take care of it, and we're going to need your help with the financial transfers. And this is where the financial transfers come in. This is basically just a graph that basically shows the climate finance. So this is basically, as of September 2016, sort of a summary graph that suggests all the amounts that's been pledged by the wealthy countries or the developed countries in the form of climate finance to developing countries. So much of this comes from bilateral public finance. This is in part the Green Climate Fund, which many people have probably heard about, which is one of the things that I worked on when I was at the Treasury Department. This is a fund dedicated specifically to promoting climate change mitigation and adaptation. Multilateral public finance, this is through things like the World Bank or the regional development banks. And then basically, if you sum this up, this gets you to 66.8. And up here, I've got the $100 billion goal. And remember, the goal was that in order for developing countries to sign on to this, to the agreement, there had to be the promise and the commitment from Copenhagen of $100 billion per year. So how do you make up for this difference? And the difference sort of comes from using public money to leverage private investment for both mitigation and adaptation products. And so projects. And so basically the developed countries have made the case that they're going to make good on their commitments to scaling up climate finance, which comes from both the private and public sources, by 2020. And one of the things that was agreed to in Paris was that then this is going to be $100 billion per year from 2020 through 2025. So you've got increasing commitments from developing countries and more money actually being promised. For those of you who are out there and looking for places to do research or have an impact, I think that one of the areas where the most work needs to be done is to figure out how this public money could be used to leverage this private finance in order to fund these projects. Because while this $100 billion a year sounds like a lot, it's actually very small compared to the challenges that we actually need in order to get reduce emissions in a meaningful way. So the Paris Agreement from afar, so this is just some reflections on the agreement. It's basically, it is true, and it's a cause for celebration of an unprecedented model of international agreement to solve a global problem. There's 192 countries involved in this agreement, and it's quite significant. It's the result of a negotiation process over 20 years. It's an adaptive framework that meets periodically every year and every 4 years, in particular to update ambition. But I think it's limited in the sense of its promise going forward. I should say something that I'm going to talk about a little bit later, but the Trump administration now, tomorrow, is supposed to have a principals meeting in the White House to decide whether or not the U.S. should stay in the Paris Agreement. So this is a very timely issue for us to discuss. Tomorrow afternoon, we're actually going to have an answer to whether or not the U.S. wants to, or we may not have the answer, but a decision will actually be made to this effect. But you may then say, well, you know, is this everyone's celebrating this great accomplishment of this international cooperation, but like, how does this actually compare to the scale of the problem? So here I've got a graph that basically shows, here we've got basically, again, time on the horizontal axis, and this is global greenhouse gas emissions, different scenarios that I'll explain, and then this is how the science sort of suggests that this will map into increasing temperatures. So this range, which represents the uncertainty, is kind of a business as usual with no policy, no climate policies. And this suggests that by 2100, the forecast is that we could have an increase between 4 and 4.8 degrees C temperature change. And that is a very significant temperature change. I leave it up to the scientists to tell us whether or not that, you know, there's a range here. Based on policies that are currently in existence, the current policy projections brings us down from the no policy scenario, and this gets us to about 3.3 to 3.9 degrees temperature change. If you then take from that and add on the additional commitments through these intended nationally determined contributions, the pledges of countries, it puts you on this path here. And this path is a 2.5 to 2.8 degree temperature change. Now, the agreement itself also says that the goal is to maintain temperatures below a 2 degree increase and setting an ambition of only a 1.5 degree increase. In order to get to that level, this is what the emissions trajectory has to be. And below 1.5, it's got to be here, which basically says, like, you know, negative emissions by 2080. So although you can sort of feel good about the international relations success of the agreement, even with this agreement, as it's rolled out to its full force, it's a future of climate change or increasing temperatures. Here, within this agreement, let's look at what the U.S. actually pledged to do. This is emissions from the U.S. over time. This is the trajectory of a previous pledge that the Obama administration made to reduce emissions 17% by 2020 levels, by below 2005 levels by 2020. And generally, we are on a track to actually do this because of a mix of policies. And the commitment, the U.S. commitment to Paris, was 26 or 28% below 2005 levels, which these things always kind of like drive you crazy. That's an additional 9 to 11% beyond what we already committed to, and that is basically this trajectory here. How is this designed to be accomplished? Well, this is basically the breakdown of U.S. emissions by different sectors, where we have electricity, we have transportation, industry, commercial and residential, and agriculture. And in each of these, there is a plan and a rollout set of policies to try to accomplish this, this goal. The biggest one and the most significant one is the Clean Power Plan to reduce emissions from power plants in the U.S. You got building codes and appliance and equipment standards. In transportation, there was light duty and heavy duty vehicle fuel economy standards. For industry, there's some HFC programs, oil and gas and efficiency programs. And then for commercial and residential appliance standards and building codes. So there's basically a this is much of what's going on here is the summary of the climate action plan that President Obama rolled out in 2013. One of the things that you could notice is if you sort of put a bullseye on each of these are the exact target programs that the Trump administration is now targeting to sort of review, evaluate, potentially roll back. And part of the reason why that occurs in some of the important politics is that many of these initiatives were basically done by executive order by President Obama, so the next president can by executive order sort of like undo them. It may take some time, but ideally, we would be having laws being passed by Congress to support this sort of thing that are not sort of subject to just a president's decision about what he or she actually wants to see. So here's a little bit more detail about U.S. emissions trajectory. So one thing that is quite remarkable, and one of the things that you can sort of feel good about, is the amount that the United States has actually reduced its emissions in recent years. A big drop here is basically the recession in 2009, but one of the things that is really interesting and that you should sort of, I don't know if you should feel good about it, but it's a little bit surprising. I would have never expected it, is how as we've recovered, emissions actually hasn't gone up. And a big part of that, the reason why it hasn't gone up is primarily because of shifts that have happened in the electricity sector. And this graph basically right here is the emissions from the electricity sector. And what's causing this is basically the technological innovation, the combination of horizontal drilling for natural gas and hydrologic fracking, which increased the supply, decreased the price of natural gas. And the way we generate electricity has had a really, really significant shift over the last decade. Other sectors are pretty much generally flatlined here. Okay, so that's kind of where the sort of regulatory framework, the international context, and some of the general policies. Now what I want to do is, I want to be careful because I'm up here because I'm an academic economist, and it's sort of you can't talk about the political economy without what's going on in the world right now. And my political leanings are, I was part of the Obama administration, so that suggests that I'm not part of the Trump administration. Nevertheless, I want to approach this and talk about it in a way that is the way that an academic, a researcher, would actually think about some of the things that are actually going on. And I want to just focus on two of the executive orders that have come out. How these are going to manifest themselves and what they're going to do remains to be seen. But we have on January 30th, the presidential executive order on reducing regulation and controlling regulatory costs. So this was not an energy or a climate executive order at all. But one of the things that got a lot of attention, and many people probably find appealing, is basically this one in and two out approach to new regulations with no additional cost. And so the idea here is that any new regulation across the different agencies that was going to be rolled out, in order to make that regulation policy, two other regulations have to be eliminated or knocked out, and there can be no increase in regulatory costs. Okay? It sounds like an interesting, if I was managing a company, that might be the approach that I would actually do because I want to decrease my costs. And if you look at the text, it basically mentions regulatory costs 18 times, but it never mentions regulatory benefits. And as a sort of like public economist, this is quite interesting. And it's interesting because let's think about the private versus social benefit cost analysis and get to the heart of what we teach and what we think of as the role of government in terms of public policy. And typically, an economist always is thinking in terms of costs and benefits, and you can think about a private perspective where you've got your benefits of a policy or an initiative and you have your costs. And from a private perspective, you think about these benefits, you can think about this as revenue, you can think about costs as costs, and the difference between these would actually be your profit from a private perspective. And if you have this perspective, and you're thinking about something just in terms of its costs, the idea associated with this actually makes a lot of sense. Why would we want to add things that add costs? But that's a very narrower perspective about what the role of actually government is and what the role of regulations are in the first place. And the public perspective is quite different. The public perspective accounts for all these private costs and benefits, but there's also social benefits associated with these policies. You can think about reducing air pollution, where people actually benefit from this. There also could be some additional cost to society, but cost-benefit analysis, the role, the theory of government, is actually that you should be considering this perspective. And it's also codified in government through an executive order that dates back to Ronald Reagan, that for large regulations, cost-benefit analysis from this perspective is actually required. So the point that I want to make is that the sort of one in, two out idea, which is builds upon the rationale from this private perspective, is actually a fundamental change in the way we think about the role of government, regardless of whether or not we're talking about climate or energy policy. To give you an example, this is basically the US Clean Air Act. And the Clean Air Act over time sort of was focused on reducing sulfur dioxide and nitrous oxide emissions. I just want to focus on the sulfur emissions, where basically in 1990 it was up here at this level, and in 2012 is down here. So this is basically a reduction in SO2 emissions of about 50%. Now, this didn't come for free. Power plants didn't voluntarily reduce their emissions, and in fact is quite costly, and the estimates are that it costs about $2 billion per year to get this emission reductions. But that's only half the story. That's the costs. Those are the regulatory costs. The benefits are estimated at over $100 billion per year, a tremendously successful program, because basically air pollution really hurts people and has human health effects. So it avoids 18,000 annual premature deaths and 24,000 non-fatal heart attacks. So this suggests that the benefit is 50 times the cost. This is the social cost benefit analysis. One in, two out doesn't actually account for any of this benefits. It would just look at this $2 billion per year. The second executive order here is the more recent one, where the presidential executive order on promoting energy independence and economic growth. So this one makes an explicit call for a review of the Clean Power Plan. So this is the Obama administration's proposal, which builds up from state programs to reduce emissions. And it also basically, that interagency working group process to estimate the social cost of carbon rescinds the whole process entirely. In fact, it's quite flattering to some of us who actually worked on this process that an executive order came out, 8 pages, and 2 pages are dedicated to specifically removing the papers that you worked on. It's a lot of attention. So, so I was flattered, and many other people were flattered in this process as well. And of course, there's still no word yet about whether or not to cancel the Paris Agreement. So a little bit of perspective on this. So in terms of the regulatory impact analysis of the Clean Power Plan, there had to be a cost-benefit analysis associated with it. And how do you think about this cost-benefit analysis? Well, the estimate is just over $8 billion in cost per year, and this is by 2030. So this is if this plan is actually implemented. It's not going to be cheap. It's going to cost over $8 billion per year by 2030. But again, there are benefits. And the benefits of it, which I've split out here, this is actually coming from the benefit cost analysis, are in 2 areas. One is the health co-benefits. The co-benefits here are if you actually reduce CO2 emissions from power plants, in other words, by shifting to natural gas or having more renewables, it turns out that a lot of other harmful pollutants get knocked out in the process, like the sulfur dioxide emissions. And these health co-benefits themselves actually are close to $25 billion per year. So irrespective of any climate benefits at all, this policy actually passes the cost-benefit test. What does that suggest? If you're someone who doesn't believe in climate change, that actually is still not a reason to eliminate the Clean Power Plan, because there's all these health benefits associated with it as well. You stack on top of this the climate damage avoided benefits, and this is the social cost of carbon. And what I've split this into is the domestic portion of the social cost of carbon, and the rest. This is the avoided climate damages that benefit other countries, whereas this is just the benefit to the US. This is that $4.50 versus the $40 associated with the climate benefits. And so how you come down on this makes a difference, but there's all these climate benefits, but even if you eliminate the climate benefits, you still pass the cost benefit analysis in this approach. The implications in this executive order to this process of the social cost of carbon is basically saying that the sort of reader's guide to what this means is that rather than having a central unified approach for the government of how to value climate damages and regulatory benefit cost analysis, it's going to be led to an agency by agency decision-making process where the EPA may choose something, the Department of Transportation may choose something else. And it opens the door to the focus on the domestic damages rather than the global damages. And of course, this makes a big difference, which I've shown you before. And it also suggests, in reference to an earlier sort of guidance from the Office of Management and Budget, changing how we value the future from a 3% discount rate to a 7% discount rate. And that is a very big normative judgment here about how much you actually care about the future. 3% says you care about the future, you know, a reasonable amount. Actually, you don't care about it enough. Many people would argue that we should be using a 0% discount rate. We should be considering future generations the same as we consider our own. 7% is a big deal. And what I've done here is I've done basically an analysis that comes from what leads to the social costs of carbon numbers. And I've got time again on the horizontal axis. And this is in 2017 dollars, the approach. Currently, the approach for the global social cost of carbon is we start here around $40 currently, and it increases through time. It increases through time because as we have greater concentration of CO2 in the atmosphere, the damages get more significant at an increasing rate. If you actually take the potential implications of the Trump executive order here in piece, if you shift from just a 3% discount rate to a 5% discount rate, I can't do 7 because the analysis actually didn't go that high. It only went to 5%. This is what happens in terms of how you would value climate damages. You go from this trajectory to this trajectory with a change for the discount rate of 5%, significantly lower. So in 2050, instead of valuing it above $80, you're valuing it just above $30. If you also shift this to focus on just domestic instead of global, I don't even know if the podium is in the way here just to see this low here, but at 3%, you actually get it to only just below $10 in 2050, but if you shift to 5%, you basically end up at around $5 in 2050. The point of what I'm trying to make here in this graph is there's a lot of research and scholarship associated with estimating these different things, and this provides the underpinnings and the justification for policy from a cost-benefit standpoint. And what you're actually seeing as part of this, this political process of issuing these executive orders is basically a direct attack on the research that underlies these decisions. So there's an academic debate that is ensuing in addition to a political debate. This slide probably gets me a little bit more on line of being partisan than I necessarily want to be, but I'm going to take the chance. Basically, how would you think about the rationalization for what you're actually seeing? And I think this is important because this is in fact important for us as citizens to engage in this process and advocating for things that we actually care about. One is that you're not convinced that climate change is a problem at all, and you think that this whole literature is, you know, out there. It's I don't know if you necessarily think it's a hoax, or you just don't think it's that big a deal. You might think that climate change is out there, but the economic estimates of how much we should worry about it are just really off. Okay? The other is that there's an approach of some regulatory capture that has actually taken place. And if you actually look at who's heading these different agencies, where the decisions are actually going to be made about doing these values, many of them are actually from the fossil fuel industry. And it's important because they're the ones that actually stand to lose the least from this process. You could also say, in the sense, one of the things that is very interesting, and if you're commentating on the policy process, is there's a lot of focus on coal and coal jobs. The entire coal sector in the United States has 66,000 people working in it, and only just under 16,000 of them are actual coal miners. So there's a lot of talk about 16,000 jobs, but I'll just have you note that just in the wind and solar sector, there's over 300,000 jobs, and that industry is actually growing. So I think as citizens, we should say, well, why the focus on these jobs and not so much the focus on these jobs? And I think that's an important thing. Nevertheless, I think that we're in a situation where there's a political imperative. There's sort of our president has been elected with the idea that he's going to change course on some of these issues, and so something actually has to be done. The backdrop here, and this comes from some survey research that has taken place at Yale on basically voter voter preferences. So this is the Yale Project on Climate Change Communication. So this is, what do people think about the climate agreement? Forget about who's going to be in the principals meeting tomorrow. This suggests that of all active voters, 70% of the voters actually think the United States should stay in the Paris Climate Agreement. Among Democrats, it's 86%. Among independents, it's 61%. And it's even 51% among the Republicans. In fact, the only group where the majority is not in support of staying in are the really conservative Republicans, in which case it's only 40%. So the population actually thinks this is a good idea. To the Clean Power Plan and the regulation of power plants, here's a graph that basically suggests this is the number of people, the percentage of voters in each congressional district that think that we should be regulating CO2 emissions from power plants. And all these sort of red and tan suggest greater than 50%. Notice that in no congressional district in the entire United States is there less than 50% that actually support regulation of power plants. So you might ask, and for us as citizens, why is this not being translated? And these are some of the challenges that we face. So the future here, and I'm going to try to sort of quicken my pace here to sort of wrap up. Where's the future? Well, I think the future is associated with, this is an economist's prescription, but if we're going to have sort of climate policy, the carbon tax is the way to actually do this. In fact, it's much better than the Obama administration's plan for regulating power plants, because it creates the right incentives to spur innovation, new innovation, and reduce emissions, and it's more efficient. In other words, you can accomplish this same goal at a lower cost, either with a carbon tax or a cap and trade program. And I think it can play an important role in sort of comprehensive tax reform and also some things that are going on for infrastructure plan. Here's basically just a graph of where carbon pricing is either taking place or where it's being considered. And this is all sort of around the world. You'd be surprised how many places it's actually taking place. And you're right there under a place where it's under consideration. And this is the fraction of global emissions that are actually subject to, based on that last graph, carbon prices. So it's almost up to 20% of global emissions is under consideration to face some carbon price. So if you're looking for reasons for optimism, there's some reasons for optimism here. I mentioned this is the Climate Leadership Council came up with a proposal about a month ago for basically, this is a Republican proposal from former secretaries of state and treasury from the Republican administration and the chairman of the Council of Economic Advisors under President Bush, sort of referred to as the Republican jailbreak strategy. In other words, they want to change up the approach to addressing climate and energy policy. This is the way out. And this is a proposal building on that social cost of carbon number of a carbon tax of $40 per ton, which is exactly economically efficient for the reasons that I talked about before. But here the proceeds would be returned. This revenue would actually be returned in lump sum payments back to the citizen in dividends. And in particular, their proposal, the estimate is for a family of four, this payment that you would get every year would be about $2,000. By the way, this type of thing actually occurs in Alaska already with royalty payments associated with extraction of fossil fuels, where everybody actually gets a dividend check. The last point that I want to make is we did a survey at Yale where we basically went around and actually said, among the population, if there was a carbon tax, how would you actually like the money spent? Would you like it in dividend payments, or would you like it through some other mechanism? And so here, this is the percent of the total expenditure. It turns out most people want basically close to 17%. People would like 17% of the revenue. Public opinion is to use it on more clean energy programs, adaptation and resilience programs, infrastructure, paying down the national debt, assisting coal workers, reducing income tax, and only down here about like 7% of this do people actually want this in direct payments. We also then sort of asked people, well, what's your willingness to pay? We did a valuation survey for a tax on fossil fuels or a carbon tax, and we came out with an average estimate globally of $177 per year. This turns out to be lower than the proposal, than the $40 per ton tax. Nevertheless, with this estimate, we basically calculated With this preference for the assisting of coal workers, it basically says that this generates enough money, $140,000 per year per coal worker. So the idea of sort of like transferring and shifting to different sectors, this is an easy problem for us to solve as a nation. We don't need to construct new coal plants and keep the coal industry in business so that people actually continue to earn the same income. This is the easiest problem that I've talked about today to actually solve. Big changes are possible and fast when the incentives are right. I'm going to just sort of, this is basically just a graph that shows where our emissions from has actually declined. Our natural gas emissions have gone up, but our coal emissions have gone down, reflecting the shift. This is a decrease in renewable energy. This is a reduction of 30% in the price of the levelized cost of solar energy just from 2010 to 2016. That is huge. A huge reduction. Same with wind, and this is the line where it's actually competitive on a levelized basis with fossil fuel. Wind is basically competitive with fossil fuel generation now. It just has an intermittency problem associated with it. So we're right on the cusp of big changes regardless of policy. I'm going to skip this graph, and here's my final thoughts and then questions. The point of putting this up, and I say that I'm not quite sure what to say about this, is the point of putting this up, and I don't think it's a coal tank or oil tanker. I think it's a freight. Maybe it is, but the point is it's a big ship, and a big ship that's moving and has a lot of momentum is difficult to turn around quickly. And so at our school, many of our students studying these issues are very discouraged. And what I like to say is that there's a tremendous body of scholarship and academic research out there that suggests that climate change and our energy challenges are really important. And it's very difficult to kind of turn that around. Nevertheless, we do get signals from our administration and the President of the United States, which ripples around globally. And this ship can turn. I don't think it could turn around in a way that sort of fundamentally changes the long-term game. But it's important for us to sort of recognize that we don't have to go crazy and think that the world is entirely falling in terms of climate change based on these executive orders. But just as it's very difficult to turn the ship towards solving the problem, it's difficult to turn it away from trying to solve the problem at all. So there's reason for hope, and we should sort of keep at it to make so that some of the sort of political economy features that I've just described and where public opinion is translates more into the political process. And with that, I'm done and happy to take any questions.
So if you just put your hand up, our student Russell Drummond will be happy to bring you the mic.
Very well done. And the speaker did well, too. Are we on? Testing, 1, 2, 3.
You're on.
Good. Wonderful speech. I agree with everything you say. I'm in the energy business, except go back a slide or two to solar and wind. You're out of date. It's 40 to 50% reduction in solar and onshore wind. We just put out a study this year. The fact of the matter is the cost of repair is declining even more rapidly than the IQ in Washington. Thank you.
Sure. I should just say this graph, it may very well be out of date, but this is for utility scale and not sort of residential, small scale.
Our study was too. But
Okay.
the good news is we're disagreeing about how good the news
Yeah,
is.
those are good disagreements to have. Yeah.
Conveniently, my question was also on this slide, and I was just wondering how high the fossil fuel line would rise if you could add the $40 Pigouvian tax on there.
I don't know exactly how high what you would get per megawatt hour, but I do know the number that sort of I don't know exactly, but I think that a $40 per ton would be quite significant enough. That would certainly tip you over the wind in this graph. And I should know these numbers offhand. People often kind of think about if there's a $40 tax per ton, what does that mean to your sort of average electricity rate and for your gas. I think in terms of how it translates into there may be people here who actually know these numbers offhand. I'm not positive about this, but I think it's a 10% increase in your price per gallon of gas per unit of carbon tax that you actually get. So if you had a $40 per ton tax, you increase your price of gas by 4 cents per gallon, I think that's right.
I have a question about how the emissions per country is calculated. I guess my main question is, with the increased outsourcing of Western manufacturing to these developing countries, is the number calculated basically the overall emissions per country, or is it related somehow to consumption?
It's a great question and an incredibly important question. And there's research on this topic. And the way that I'll reframe the question is, you see a decrease in emissions in the U.S. over the past decade or so. And the question is China's emissions going up while ours goes down because we're buying a lot of our stuff and importing it from China? And I think the answer to that is that's definitely going on, for sure. I think that the estimates say that the extent to which you might think it's going on is a little bit less, because there's sort of changes in sort of what people are buying, where it's being consumed. So that's definitely going on. But the next step is, so even when you understand that, okay, right, that your carbon footprint in the U.S. is based on, different countries and where you buy and consume things, sort of the way that we actually do our sort of regulation and think about policies is on a country-by-country basis. So you could start to think about having taxes, border taxes for imported goods and various ways to get at the problem, but the accounting of your footprint and where it goes is kind of an interesting exercise, but it doesn't help in terms of thinking about how you would actually come up with policies which have to take place on a national basis.
Well, I guess just the international moral responsibility of various countries, if it's shouldered on, if, say, China and India have this, this appearance that their emissions are increasing, when in fact they're just making a bunch of our stuff that we buy. It doesn't seem fair.
I'm always a little uncertain when I'm moving into discussions about what's fair or not, because people have different views about what's fair, but many people would say that, for just in response to that China benefits a lot from that trade, and the people actually benefit from it, and so it not necessarily fair is that they should reduce their emissions because they're also benefiting from it as well. So how you act. What we can agree on is it raises important questions that need to be addressed. What the solution is, that I don't know, and we'll have to discuss that one some more.
Hi. So clearly, climate change is a global and national issue. Speaking at a state legislative perspective, does it make sense for states to individually manipulate their markets to reduce their carbon emissions when it puts them at a disincentive against their region? And should they wait for the larger bodies to make action instead?
It's a great question, one I've actually talked about quite a bit throughout the day today, where from the collective action decision-making model that I just showed you, it doesn't make a lot of sense for individual entities, say, such as states, to actually, in the context of that model, incur real costs to reduce emissions when they're relatively small compared to the global problem. Nevertheless, you see this sort of happening all around. And why is it? Well, I think that there's different ways of people actually care about these issues, and this model is not complete. People care about not feeling responsible for contributing to this intergenerational problem, and they also think that you can't wait for the international bodies or the nation as a whole to do this. We need to provide models about how it's possible and demonstrate leadership. And I think that you certainly see that in California on a range of environmental issues. Only the most recent one is their climate policies, and it's sort of coming up the West Coast here as well. And I know, for example, that the structuring or the drafting of the form of the Clean Power Plan, which started on a state-by-state basis, model of federalism and aggregated back up, was very much built upon what was actually taking place in California. So the idea of states being the laboratories of policies for higher levels of government, I think this is an example where that actually takes place. But I sort of applaud the states for actually doing this, because it is sort of taking one for the team, you might say, where the team is quite big.
Thanks, and thanks for being here and giving the presentation. I'm curious, so in the game theory model, that country A, country B, and then given that the Paris Accords are voluntary, what argument would you make to a policymaker like the president that moving from a global valuation, $40 per ton, to a domestic valuation is economically irrational?
It was exactly the research seminar that I gave yesterday entitled Which Social Cause of Carbon? And the idea is that what that model misses, the simplified model that I just mentioned, is that this is a dynamic game over time. It's not a one-shot time. And over time, you can get different outcomes that are individually to your advantage. So in other words, if we're engaged in some sort of game back and forth, what is to my advantage right now in this one-time period might not necessarily be what is to my advantage over time. So if you have a dynamic game, it actually can change the calculation. But that depends on how much we actually care about the future. The other way that you can justify it is that that model, in the sort of Nash equilibrium way to study that problem, sort of assumes that my behavior does not affect your behavior, where I take your behavior as given. Clearly, that's not actually what goes on in the real world. In the lead up to Paris, there was a meeting in Sunnylands with the Chinese government, with the U.S., where they basically got together and said, "All right, well, what's your INDC going to be, and and there's sort of some coordination where both those large countries clearly did not assume that the other's behavior didn't depend on their choice, and so there's a different way to kind of model that, and if you think there's some reciprocity associated with that, then you can actually get different outcomes. And I think that actually plays. And one of the things that I've actually been working on for research is actually building the case for that, precisely because I think it's important with the challenges that we see coming out of the Trump administration now, whereas if I was to reflect back on what was happening during the Obama administration, this notion of domestic focus versus global focus, the truth is the politics of it were such that people didn't want to talk about that. They didn't want to draw attention to it because they knew that it was a source of potential legal challenge. But now there's sort of like a vacuum, and there's not enough of a scholarship and research on justifying this decision. And I think that that's where you're going to see a lot of action in the coming years.
Hi, I had a question about your tendency to refer to taxes as opposed to cap-and-trade programs. From an economic perspective, my understanding is that if your goal is to actually reduce carbon, cap-and-trade allows you to do it at the least cost because you can find the entity that has the lowest cost of creating that reduction, whether it's through offsets or otherwise, and therefore it's better for the economy. And you, through cap-and-trade up once or twice, but mostly default to a tax. I was wondering from an economic perspective if you could elaborate whether that is an intentional decision or whether that's just a shorthand.
How much time do you have?
I have all legislative session.
In a very simple model of thinking about these, and I think that it is the case that economists, particularly academic economists, are a little bit too flippant about the equivalence between these. With a cap-and-trade program, you know what your emissions is going to be, but you don't know what the price of the permit is going to be. With a tax, you know what your price is going to be, but you don't know what the quantity of emission reductions is that you're going to get. Under certain sets of assumptions, these two things are exactly the same and are equivalent. In the real world, they're very different in terms of the political feasibility, what people actually think about them, and how they arise. I was talking to I was in a conversation earlier today where I had an interesting conversation with a lawyer who said that, economists always like cap and trade because it's in their territory. They can talk about efficiency and they can talk about how they allocate the permits. The lawyers tend to like the tax because they're used to writing tax codes, and they accomplish the same thing by adjusting the tax codes and establishing property rights instead of a cap and trade. I would say that there's a lot of interesting and important things about these two mechanisms in terms of their feasibility and how they would be administered. I personally think, based on the academic research and what you see, I don't care either. I'll take either one. Either one, both of them create the efficient incentives, and you can accomplish the same thing through both mechanisms. So if you're sort of an advocate and you want to see the policy, I say go with whichever one you think can actually get passed.
My question relates to the cap and trade program on the East Coast. I'm curious about how efficient you think that these regional programs can really be, because I remember hearing somewhere that RGGI, the amount of leakage was pretty extreme, difficult to account for, how much they were simply outsourcing their abatement versus actually doing it. And I definitely believe that sentiment is important, and that steps in the right direction should be encouraged, but how efficient can these, small regional initiatives really be?
Well, the generic answer to that question is the smaller they are, the less efficient they can be. So the larger they are, the more gains from trade you can actually happen and reduce emissions more efficiently. I think in terms of the leakage question, I think that the program that we have in the northeastern states, which I think is what you're talking about, the price is not high enough to really be affecting behavior and decisions. So the idea of having leakage, conceptually it's a problem. I don't think it's a big enough problem because the price is not so high that it makes a lot of sense to pursue leakage. With the programs that are being designed on the West Coast and the aspiration, leakage is a big problem, and there's mechanisms to try to sort of limit that and where you draw boundaries and what's in and what's out. And there's a lot of interesting work about that, and the stakes are actually high in terms of that. But having so leakage is an important problem. And then the other sort of related idea is the extent to which offsets are allowed, where you can actually buy your emission reductions outside of the market that you create. And each time you kind of relax one of these or have these problems, it affects your efficiency that you would have from the program. So there's a lot to designing these programs.
You mentioned that 192 countries are party to the Paris Agreement. Most of those, or at least half, are low and middle income countries. I've had a look at a number of the INDCs of the developing countries, and a number of them say, yes, we're all in if we get sufficient flows of resources. That basically, if we get enough finance to make it happen, we'll contribute. Having worked on climate finance, what do you think the prospects are of those flows really happening and those investments really being made in the low and middle income countries?
They were better at the end of last year, at least from the U.S. Perspective. But I think that it is a bit of what I sort of hinted at. How you actually count financial flows in climate finance, what's in and what's out in those numbers that I showed in that graph, there's judgment calls associated with whether or not something is actually climate finance or not. If you have an international development project to build a seawall in an area, is that climate adaptation now, or is that something that would have happened anyway? So there's a lot of accounting associated with this. And I think that that's one of the reasons why the Green Climate Fund became such a flashpoint and a hot thing in the run-up, was because it was the creation of a new fund, a separate pot of money that countries made contributions to, that you could specifically point to and say, this is definitely additional money that's coming from developed countries for climate finance. Now, the amount of pledges that were given to that were $10 billion. The U.S. pledged $3 billion. We paid $1 billion of that into it. The prospects of us paying more over the coming years are probably quite low. But that's an incredibly small amount of money. And it turns out that the Paris Agreement sort of hinged the Green Climate Fund and whether or not it was actually going to be capitalized. So a $10 billion sort of fund sort of was the symbolic importance associated with it. But I think that there, many developing countries use this as leverage, and there are lots of opportunities for finance. But I think that what you see is that there's a direction in terms of shifting international aid from many banks and the types of projects that you probably work on and study from the World Bank to tilt them towards more climate-related projects. I think the World Bank has a goal of something like 35% of its investment should actually be climate-related. How you define climate-related or not, I'm not. Those are contentious issues. But you also have another interesting feature that is associated with getting the appropriations and getting the money, not just from the United States, but from developing countries as a whole to transfer, is that the fact of the matter and the truth is that many developing countries want climate finance to help fund adaptation and resilience projects because those are the ones that promote development. They actually don't want climate finance to promote mitigation, emission reductions, because that's a global benefit and they want the other. So you have all the donor countries wanting to fund more mitigation and not adaptation, but the recipient countries wanting more adaptation and less mitigation. And so there's kind of a debate there in many of these institutions. So what you end up by saying is that 50% should go to one and 50% should go to another. And then the maximum amount of money that can go to this country is this bin. So it kind of gets parceled up in lots of different ways. But I think that the goal is really to get at finding ways to like mainstream climate in development programs, but also finding ways to create the levers for more private finance, because the amount of public money that you're ever going to mobilize for this is not up to the task.
I'm okay. So I guess my question is, and I'll see if I can try and frame it right. First of all, I appreciate everything you said. But it seems like we're still sort of trapped in a framing problem that favors fossil fuel companies. So you're talking about like my interests are the same as Exxon's. So when you talk about national interests and countries paying, we have a problem because we have a political problem because people are like, gee, I don't know if I want to pay. But who should be paying? Us? Or massive fossil fuel companies that have, billions and billions of dollars of assets and have lied over the course of 30 or 40 years about their culpability to climate change and have misled the public. It seems like we need to be a little more aggressive in terms of where we get that money, and that it really ought to be coming not so much from countries, but from those that have profited off fossil fuel companies for the last few centuries.
I'm sympathetic to your view there in some ways, but not other ways. I guess as an economist, I don't sort of think of necessarily these big bad, if you're the lied to or information campaigns, that I'm going to set those, my comment that I'm going to make now doesn't apply to that. But the people, the group that has benefited from the consumption and use of fossil fuels far more than Exxon or BP or any of those countries are all of us. We've gotten a tremendous amount of surplus and benefit associated with those fossil fuels. So the idea of saying it's them and it's their problem and they should pay for it, I don't think is the right way to think about the problem. The right way to think about the problem is setting up incentives to make it more costly for both the consumers of that and the producers of that to make other things actually more competitive. I don't sort of believe in kind of like that fossil fuel companies should pay some sort of punitive damage associated with us having burned the fossil fuels in the past, because we've all benefited from it. It's been a sort of a supply and demand setup.
Setting aside the lying.
Setting aside the lying part.
Well, I'm afraid we're just a little bit over time, and so I'd like to go ahead and cut us off there. But do please join me in thanking Matt Kotchen for his presentation.
Thank you all.